So this is a short video on how to find the intervals of concavity and inflection points for a function. So here is a function. So the idea is to find the places where there is concavity and the inflection points. Okay. So what you do is you start with the functions. We know that the functions change concavity when the second derivative's sign changes. So the first thing to do would be to find the second derivative. So first you take the first derivative, which is what? So we differentiate this. The derivative of 2 is 0. The derivative of 3x squared is 6x. And the derivative of x cubed is 3x squared. So you get 6x minus 3x squared. But because you want the second derivative, you differentiate this again. And then you get 6. And minus, when you differentiate 6x squared, 3x squared, you get 6x. So you want to find out where the second derivative changes sign. In order to do that, it changes sign. First, you need to find out where it is 0. So what you do is you take the second derivative and set it equal to 0. So you put 6 minus 6x is equal to 0. And then what happens is you factor out the 6. You get for 6 times 1 minus x equals 0. And which will give you x equals 1. So now what you do is just like the first derivative test, right? So 1 is an important point. That's where the concavity, if it changes, will change. We don't know that. So what we do is we draw a little table. We take two intervals, negative infinity to 1, because that's the place where it might change. And then the other one will be 1 to infinity. So only the second derivative changes we are taking into consideration. So so what happens now is you take a test value from this interval, you get 0, and you take a test value from this interval, which is 2. And when you plug in the test value 0 in this second derivative, which is this, right, which is actually this, before you set it equal to 0, so you put 0 there, you get 1 minus 0 times 6. 1 minus 0 is 1, so that is positive, which means it is actually concave up in this interval. And if you look at the other interval, 1 to infinity, then you take the test value 2, and you put 2 here, you get 1 minus 2, which is negative 1 times 6, which is equal to negative, so it's concave down in that interval. And so we know that it is concave up in this interval and concave down in this interval. So it changes the concavity at 1. So 1 is an inflection point. Is an inflection point, and you can find the coordinates by taking that and plugging it in the original equation, which is this. And then you get this, the y coordinate as 4. And you can actually see by Wolfram alpha, you got the graph of this function. You can see that at 1, it goes concave up and then changes to concave down at 1. You can see how the concavity changes at 1. Okay, so that's it for this video. And we will see you in another video shortly.